With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? Consider the situation in which one end of the massless spring of a spring constant K is connected to a cylinder of mass M and the other rigid support. Now when the cylinder is given a gentle push in the horizontal direction, it starts oscillating on the this rough horizontal surface. So this is a cylinder. When we have given a small push, so it is starting in motion on this surface. Now the motion is oscillatory motion and the time period is given as to be t equals to 2 pi 2m divided by 2k, and x is basically given as a sine of omega t. Okay, so time period is given like this, and this x is given a sine omega t. Now we need to find what is the minimum value of the coefficient of friction such that the cylinder does not slip on the surface. We need to find the minimum value of the coefficient of friction. So how can we do this? So basically this is a cylinder, we just make a cylinder. Okay, so this is a cylinder and it would be having a velocity and it would also be having an angular acceleration. Let's say it is having velocity and acceleration. So let's say acceleration is a, velocity is v, and angular acceleration and angular velocity is omega and a. Now what will happen? So when we have given a push, so there would be a this spring force which would be acting in the backward direction. Okay, so this is basically the direction kx. Okay, and there would be a friction force at the surface. Okay, so this is the frictional force at the surface. Let's say frictional force value is F, and we know that F value should be less than, F value would be less than the maximum friction value F max. Okay, should be less than or equal to, or we can say that it is less than or equal to mu n. Okay, now if we apply torque balance about this point, if we apply torque balance about this point, what we will be getting? So there won't be any torque due to this kx, so we can just say that Fr, the torque due to the frictional force Fr would be equals to I into alpha. Okay, what is the moment of inertia of the cylinder about the center? It is mr square by 2, mr square divided by 2, mr square divided by 2 into alpha. So from here we can get the friction value as F would be equals to m by 2 r into alpha. Now if this is a case of pure rolling, okay, so we can say that A would be equals to r into alpha. So we can say that our F would be equals to what? It would be equals to m by 2 into A. M by 2 into r into alpha would be equals to A. Okay, this is the acceleration. Now this is given as the, because the particle will be executing a S.H.M. So x is varying with a sine of omega t, and time period is also given. So we can say that if x is executing S.H.M, then there would be displacement is executing S.H.M. Then we can say that our x or acceleration would be, if we just write a equation, let's say x equals to a sine of omega t. If x is given as a sine of omega t, then we can say that v would be equals to a omega, then cos omega t, and then our acceleration would be, we just differentiate this equation, so it would be minus omega square a cos of omega t, or we can say that we can directly write this expression as a would be equals to negative omega square times displacement. Okay, this is a standard equation. Now what is the value of omega? We know that time period is given as to be t equals to 2 pi under root 3m divided by 2k. So from here time period we can say that omega would be equals to 2 pi by t. This is the value of omega whole square into a. Similarly we can just write here as 2 pi over t into t. Now if you put the value of the time period as this, so this term would be cancelled and we would be having 3m divided by so it would be 2k divided by m square, because it is the reciprocal. So here it is the reciprocal, so we can say that our acceleration would be 2k divided by 3m. Since it was in the square root, so square root if we just apply, so because this is a square, so it would be gone. Then we can just write here as cos a cos, then 2 pi by capital T into T. We just write it like this. Okay, now our this friction force is given as what? M divided by 2 times A. So if you put this into this expression, so our frictional force would be equals to M divided by 2 into this factor. So we just take minus here, so it would be 3k by 2k divided by 3m, then A cos 2 pi small t by capital T. And this is not 3, but this is 2. Okay, so this 2 and this 2 would be gone. Then our frictional force value would turn out to be K A divided by 3 and then minus times, and then it would be equals to cos of 2 pi T by T. Now, we know that maximum frictional value would be less than Vn. And from here, what would be the maximum frictional value? So maximum frictional value would be this amplitude, because cos would be having a value, maximum value as +1 and -1. Okay, in the positive sense, just magnitude wise, it would be having a value of +1. Okay, so the maximum value from this expression, we say that it is equals to Ka divided by 3. So this is the maximum value or the amplitude in the value of the friction, and it should be less than our mu n. Okay, it should be less than our mu n, less than or equal to. So in the limiting case, what we can say that Ka by 3 in the limiting case would be equals to mu n. Then we can say that our n would be equals to Ka divided by 3 mu. Mu would be equals to, we can just say mu would be equals to 3a divided by 3n. And what is the n? If we just see this equation, n would be just equal to mg. Okay, because it is placed horizontally, so we can say that it would be equals to 3 Ka divided by 3 mg. Ka divided by 3 times mg. So this would be the value of the friction force. This is the if we check which option would be the correct option, Ka divided by 3 mg. So D. So this is the minimum friction value. So friction value would be greater than or equal to this value. So hope you have understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.